2NURFM, a broadcast service of the University of Newcastle.
It's great to have in the studio Professor John O'Connor. We're talking about Hyperloop and Hyperlink and Hyperloop train, the ability to go from Newcastle to Sydney in 10 minutes. And we've been nattering away about this, and it seems it's been 12 months since someo's talked about a very fast train.
It's that time again, Todd, yeah, almost once a year.
10 minutes, that's a pretty quick trip. So Hyperloop, explain the concept of the train.
Well, I'm not sure about 10 minutes, but so the idea of the train is that it overcomes the real tyranny of travel, and that is friction and drag. So in the case of train, you know, if you've got a high-speed train, it's running on rails, it's got drag and so forth. A plane overcomes some of that because, it doesn't run on rails, so you've only got drag, and it flies at high altitude where there's less air, so there's less drag. But the idea of Hyperloop is to really take it one step further. So you put it in a tube where you don't have friction, you don't have wheels. You either use air support, a cushion, a bit like a hovercraft, or magnetic repulsion.
Gotcha.
And then you suck out 99.9% of the air. So rather than being reduced air pressure as it is in high altitude, it's 1,000th of an atmosphere. And you fire this thing up, you accelerate it with a linear motor. It's just like the normal rotary electric motor, but sort of laid out flat. So it accelerates up. And then because there's no drag, it coasts. So until it reaches a slight incline, then it's going to just coast along at, say 1,000 kilometres per hour.
Well, that's quick.
And, if you're doing Sydney-Melbourne, if you don't stop on that route, then that's an hour. It's less than an hour, actually. So the idea is that you're travelling the sort of speed of an aircraft, but it's all down at ground level. You can use solar as your power source. There are a few engineering challenges in there, but
but the science is sound.
Oh, the science is sound. That's right. The engineering challenges are always there, but that's what the engineers earn the big bucks for.
All right,
but certainly, yes, you've reduced the drag. All the major forms of drag.
All right, let's look at a couple of things. Obviously, people keep throwing up the Newcastle to Sydney because it's a case of we need, this is what we want. And you were saying off air, you want to be able to do the trip quicker. We'd have to forget about the current line, wouldn't we? Because basically it's lovely. It winds around the Hawkesbury, it winds all around. It's a whole new thinking of the actual line or the tube, isn't it?
That's right, because this thing's travelling so fast that you're not going to take sharp bends. I mean, travelling at 1,000 kilometres per hour...
Would you spill your coffee, would you?
You'd spill your person. It can accelerate very fast. I mean, you actually accelerate faster than a plane. That's the intention. But once you're up there, you're travelling at a constant speed. And if you're travelling in a straight line, it's just going to be really smooth all the way. But you take a bend, and it's going to be like a plane. When a plane turns, it doesn't just sort of whip around here. It whips around between here and Singleton to do a right-hand
Not when I fly, buddy.
But you're travelling a bit slower. You haven't been doing 1,000 kilometres per hour yet. I know.
No, you're pretty right about that.
But planes take big loops for good reasons, and so would such a train. So it's got to be straight as a bullet.
Okay, so how fast would it speed up, and what would the effect be? We've all seen aircraft carriers where the fighter plane is launched via a catapult, and you see the pilot, she or he, get thrown back into the seat. Would it be gentle, or would you experience the same kind of thing?
If you sat in a plane at takeoff, one of the large planes, you're probably getting about a quarter G. You can actually work that out by looking at the curtains and see what angle they swing back at.
I don't travel in an area that has curtains, but that's okay. I'm not a professor.
No, I sit in the bit back behind the curtains, the economy section. But anyway, you can work out roughly what its acceleration is, about a quarter G. In the plan for the Hyperloop is that it would be about that, about half G. So yes, it would push you back in your seat, not as much as those aircraft carrier things, because you've got a longer distance to accelerate over. But you accelerate up to 1,000 kilometres per hour, and then there'd be no acceleration. You'd be coasting thereafter. So for most of the trip, you
could get up, walk around. There's no
problems.
Well,
it's not going to be that big. The whole tube's only going to be about 2.2 metres.
Will they have a lavatory? Well, you're not going to need it, are you? Because you're going from Newcastle. You can't hang on for 10 minutes.
I think you should go before you go. If it's Newcastle to Sydney, it's very quick. Presumably if they did it Newcastle to Sydney, they'd stop somewhere at the Central Coast. It won't be quite 10 minutes. But certainly it would be a lot quicker than now.
Now we know about the takeoff. How long would it take to slow the train, for want of a better term, down?
I haven't seen any figures on that. You probably wouldn't slow it down at the same rate as you're accelerating, so a bit further, but still, it's not. It's a similar sort of thing to landing in an aircraft. You hit the runway and hit the brakes.
Okay.
And yes, you can feel that, and they can do the same thing with the Hyperloop.
Is it being used at this stage anywhere in the world that you're aware of?
The answer to that is no, but it's interesting because there's a long history to this sort of concept. In fact, many of the older people around Newcastle remember the pneumatic tubes that used to be in stores.
Yes, money in, yep.
That was very similar process.
As a child, I never knew where they went. They just disappeared.
That's right. But actually, the first use of a concept like this was actually not so much the electromagnetic thing, but the atmospheric engine was actually developed in about the mid-1800s. And that was using, again, a vacuum tube and air atmosphere one side, vacuum the other. And it could actually take trains where steam couldn't. It could take them up quite steep inclines. So certainly the old versions have been in use. But the Hyperloop is still something which is being developed. They've developed the drive systems. And in fact, you can see videos of the linear acceleration motor and it running along. But no, the developing the tubing is... and the thing to go in the tubing is a challenge because this would be the biggest vacuum vessel on the planet. I know NASA's got some pretty big buildings, which are vacuum buildings, for simulation of space. But this would be more than an order of magnitude bigger.
So it may not happen overnight, but it will happen.
Yeah, well, we'll see. If we can get over the engineering challenges and if it becomes financially viable.
Professor John O'Connor, thanks for having in the studio.
Thanks, Tom.
There you go. I wouldn't be booking your train ticket just yet.